This was the last week homework, Newton laws. First question, page 10. So in this question, page number 10, that's question. This is a continuation, like a man pulls a box towards him and with a constant speed by pulling on a handle as shown. So these are the forces which are given. So in the question they mention the man increases his pull on the box. The man and the box start to move together in the same direction and acceleration is 0.2. Calculate the frictional force between the ground and the man. Mass of the man is 90 kilogram. So we need a frictional force as the box and the man both are accelerating. So it means both have the same acceleration. We know resultant force, like there's a force which is pulling the box, another frictional force opposing, and the resultant force is equals to ma, and that resultant force is producing an acceleration of 0.2. So first we will use the formula F is equals to ma. Now what is the total mass? If you check the total mass, the mass of a person or the man is 90, and what is the mass of the box? The mass of the box is 85. So what will be the total mass of box and the man? That's equal to 90 plus 85. So 175 will be the total mass. So first, the mass of both men and the box, that is 90 plus 85, that's equals to 175 kg. Now using this mass, first we will find the force, the frictional force. So what we have the formula F is equals to ma. So what is the total mass? The total mass is equals to 175 multiply by acceleration. So what is the acceleration? Acceleration is equals to 0.2, 0.2. So that's a resultant force. 170 multiplied by 0.2. Sorry, 175 multiplied by 0.2. So what's the answer? 175 into 0.2. 175 multiplied by 0.2. What's our answer? That is 35. So 35 Newton is a resultant force. Now, what we need, because we need a frictional force. So if we need a frictional force, because if this is a box, the resultant force is 35 Newton. The force of the man minus the frictional force, what we will get? We will get the resultant force, which is 35. What is force of the man? when it was moving with a constant speed, show that the pull of a man on the box is about 400. So it was about 400. And what we need, the frictional force on the man, the resultant force is equals to frictional force minus the force which is opposing the motion. So in the, because it is related to the parts, the frictional force is there, the frictional force, and the man is the pull by the man onto the box. It was making certain angle, it was making 35 with, and show that the pull of a man on the box is about 400. The frictional force between the box and the ground. So when we calculate the frictional force between the box and the ground, that was coming out. I will solve the whole part because it is related. All parts are interrelated, so you can understand. The first one, identify the pair forces that have the same magnitude as due to Newton third. So the forces which you will identify, the Newton pair forces, the pull of a box and a pull of the man on the box, that will be the Newton pair force. Because this is the diagram which is representing the action and reaction forces equal but opposite in direction. This is free body force diagram for a box, and this is a free body force diagram for a man. And then one difference and one similarity is how the Newton pair forces are different. So they're acting in opposite direction, and how they're similar, they will have the same magnitude. The angle between the pull of a man on the box and horizontal is 35. The mass of a box is 85, show that the pull of a man on the box is about 400. Normal contact force is given 620. So pull of a man, it's making angle 35. So this will be 35 cos, uh, sorry, if this force is there, say F, so this will be F cos 35, and this will be F sine 35. So F sine 35 is acting up, normal contact force is acting up, and weight is acting down. And F cos 35 will be equal to the frictional force. So in the question, the angle between the pull of the man, a man is pulling with an angle of 35, and the weight is acting down. The normal contact force is 620. How to get the weight? It will be 85 multiplied by 9.8, so we will have the weight as well. So this one is F cos 35. Frictional force is there, which is opposing, and with an against the angle will be F sine 35. So the two forces, because it is not accelerating in the plane, the vertical plane, so we can say 620 plus F sine 35 is equals to the weight, which is 85 multiplied by 9.8. So using that, 85 multiplied by 9.8 minus 620 divided by sine 35, what we will get? We will get F, which is about 400. So it's not like exactly 400 will be there. It's about 400. You will get that. Answer about 373. When you solve this for F, so F will be equal to 373 newtons. Now, after getting this force, the box move at a constant speed toward the man. Calculate the frictional force. If it's a constant speed, because the forces must be balanced, there is no acceleration when there's a constant speed. So as there is no acceleration, the forces are balanced. So we can say that F cos 35 is equals to the frictional force, and F is already we worked out, which is the the pull of the man, which is 373. So 373 cos 35, that will be the frictional force. So 373 or 370 cos 35, which is about 310. Or if you use 9.8, like F will be 3. If you use the value like 370 cos 35, that will be equal to the frictional force. So which is about 310. So frictional force between the ground and the box is 310. Next part, because calculate the frictional force between the, now it is accelerating. The man increases his pull on the box. The man and the box start to move together in the same direction with an acceleration of 0.2. Then we have to calculate a frictional force between the ground and the man. So basically, as we know, the pull of the man is there, he's increasing the pull. So as he increases the force, the friction force increase to some value, and then it will not. That's why it is accelerating. So for this part, when we calculate the force, we have the formula F is equals to ma. Because both men and the box are accelerating, so the total or the combined mass will be 85 plus 90, and that is multiplied by the total acceleration, which is 0.2. So F, when we multiply these two, we will get 35 Newton. Now, after getting, this is a resultant force, and the previous friction, basically the friction on the man is same as the force which is responsible for, because if man is pulling, like example, if the man is pulling this, so the friction of the man is same as the force which is causing the motion. Resultant force will be there, so the friction of the man is the same as the force, horizontal force. And what was the previous friction? The friction between the box and the surface, that friction was 310. And you have, because a man which is having a mass of 90 kilogram and the box is having a total mass of 85, so the friction of the man, or friction between the man and the surface, is the force which is trying to move it, and the friction between, because like as a man does not slip, the friction of the man is equal, is the force which is responsible for its motion, and the force which is opposing the motion is the friction of the box, which is about 310, or your previous answer, it can be 305 as well, is equals to ma, and the resultant force is equals to 35. Acceleration is 0.2. So F, the friction of the man, minus the friction of the box, which is 310, is equals to resultant force, which we already worked out, equal to 35. So when minus is there, other side it will move. So it will be 345 newtons. Is it clear? Because man increases his pull on the box, the man and the box start to move together in the same direction. We have to calculate the frictional force between the ground and the man. So frictional force between the ground and the man, that will be higher as compared to frictional force between the box and the ground. That is why the box is accelerating. Is it clear, this part? Then next question. Because the part was interrelated, that's why I have to go through all questions. Question number 20B, page 14. B. Okay. In this question, the following is a distance time graph is obtained for a car. Show that the maximum speed reached between 100 and, so we have to show the maximum speed is this. Basically, maximum speed, what you have to do, you have to draw a tangent, because the distance time graph or displacement time graph, the slope represent the speed. So when we draw the tangent, which position we have a tangent, steeper tangent, that will be the maximum speed. So which position we have a steeper tangent, if we try to draw, at this point it appears that we will have a steeper tangent. So when we have a steeper tangent at this point, tangent should not intersect, it should only touch the point. So we will use the values of this tangent and use the formula y2 minus y1 over x2 minus x1 and work out the velocity or speed, and that answer should be in the range of 100 to 150. So you have to draw a tangent with a steeper slope. The one which is steeper slope means the maximum velocity or speed is there. And find the gradient. Distance time graph, the gradient represents speed. Now sketch the shape of the corresponding speed time graph. So we have to sketch for a speed time graph. Now first, what is happening? The slope is increasing till this point, like better with the time interval, so you can have, then the slope is decreasing, then the slope is constant. And what is the maximum speed? The maximum speed is from 100 to 150. So that's the maximum value of the speed it reaches. So for distance time graph, the slope represents speed. So first, what happened? The speed will increase, then it will decrease, and eventually the speed will be zero because the slope is zero. And at which point it is maximum, around which point it is maximum. So You can see at this point around, so slope is increasing, so speed is increasing. Around this point it is maximum till around, like, I guess it is 1.4. So around 1.4 it is maximum speed. Then from 1.4 to 3.2 it is start to decrease, and from 3.2 to 3.5 it is 0. So if slope is increasing, speed should increase. So speed is increasing till 1.4, around 1.4 or 1.5, and then start to decrease around 3.2, and then it will be 0 speed. I'm using the black line for, so now it's red. So this will be the graph which shows that the speed increases and then the speed will decrease and eventually the speed will be 0. Then next question is page 15, 16A2. Now, both cases, the rate, they did not mention the rate. So if they did not mention the rate, like the rate of change is not mentioned in the graph, that's why it will not be a curve. If it is curve, so here the speed increases, then the speed decreases, and then the speed will be constant. So the distribution of the mark is for mentioning that speed is increasing, then speed decrease, and then speed will be 0. For the next part, the boat is placed in water and the fan is switched on, the boat remain at rest. Add labeled arrow to the diagram to show the 4 forces acting on the boat in this situation. So as I mentioned, the boat is not moving or the boat remain at rest. So it means the vertical forces and the should be balanced with the vertical forces will be balanced and horizontal forces will also be balanced. So basically, there is a push of the fan on the sail. There is a push of the air on the fan because at its hit, the weight will act downward, and the upward force is known as the upthrust. So upthrust will be there. That's the upward force. So vertical force will be there, upthrust, the down and the weight, and the downward force will be there, the force of the air which is on the sail, and force of the air on the fan, because as the air hit the sail it bounced back and it collide with the fan. Next is question page 16, question 16b. A physics student suggested that the boat is more likely to work if the fan is reversed. Means in opposite. Suggest this explanation. Means what happened? The student suggested that if we connect the fan other way around, like the fan is attached to other side, So more likely it will work. So why more likely it will work? Because what happened in this case, according to Newton law, as the fan pushes the air will push the fan in opposite direction. So now on the sail, there is a resultant force because there's a force on the air and there's a force on the sail. So now there's a resultant force, and when there's a resultant force, the object will accelerate. So why reversing the fan? It will work. Like initially it was not working. The moment we reverse the position of the fan, why it will work? So basically what happened? There is a, because the fan will push the air away from the board, and then the force from the air is on the fan. So this will create a resultant force on the board. Previously, why it was not why it was not accelerating? Because what happened? The fan is pushing the air is pushing the fan. But what happened? Because there is also a sail, so there is a force on the sail, and like force of air on the sail, and there's a force of sail on the air. So this does not create any resultant. This does not create any resultant. So as this does not create any resultant, what will happen? It will not move. But the moment we reverses, the moment we reverse the position, so now what happened? Because there is a air, the fan is pushing the air and air push the fan, and that force create a resultant force. That's why this will accelerate. Is it clear? Then question page 18, question 18a. The cross section of a wing of a bird in aerofoil shape. In order to fly higher, the bird can tilt its wing more. It tilted them too much, as shown the diagram below. The airflow above the wing become turbulent. Turbulent means like become random. Complete a diagram above to show the airflow around the wing. So airflow at the top become turbulent. Turbulent flow means like random. So when we represent, so at the bottom it is laminar like streamline, but at the top it become turbulent. Turbulent means like random, it will, the particle will move. So we have to show this, these streamlines which will intersect. This about the airflow, the fluid flow is the next chapter, but because that's related to the part, that's why I included in the assignment. The next question is page 19, question number 18, B2. Okay, so the tilt of the wing result in a air exerting a force on the wing, which is called the lift. The lift force is perpendicular to the wing. The total vertical component of a lift produces by both wings when tilted at an angle of 20 to the horizontal is enough to keep the bird flying at a constant height. The mass of the bird is 0.063. The direction of the flight is given. Show that the total lift acting on the bird is about 1 Newton. So how we can work out? So basically we need the total lift, like this lift we need. The weight will act downward. An angle here, when we draw, like work out the angle. An angle exactly with the inclined surface will be same. So this angle will be 20. The weight is acting down. So the one which is with an angle, that's W cos theta. So basically lift is equals to W cos theta. And W sine theta will give us, or W sine 20 will give us a force which is balancing with a horizontal force, and W cos theta is balancing with the lift. So when we substitute the value, the weight is acting down. So W cos theta or cos 20 is equals to lift, and just we can substitute, get the weight, which is mass multiplied by gravity, 0.063 multiplied by 9.8 into cos 20. So we will get the lift. In the next question, assume that the only forces acting on the bird are the weight and the lift. Calculate the acceleration. So we have to calculate the acceleration. How to calculate the acceleration? To calculate the acceleration, mass is already there. It means we need a resultant force. So how we can get the resultant force? Basically, as I drew the previous question, I drew the figure. The weight was acting, it is at a constant height. So if it is at a constant height, it means that the W cos theta was equals to the lift, or W cos 20 was equals to lift, and W sine, this W sine 20 will be equal to the force which is required, because there is no other force which is opposing the motion. So it means that is causing an acceleration. So what is the acceleration? F is equals to ma. So that's a resultant force. And what is the resultant force? W sine 20 is a resultant force. M is a mass, which is 0.063 multiplied by A, that's acceleration. So weight is there, M into G, mass into gravity. So we will get the weight, and weight divided by 0.063, uh, weight into sine 20 divided by 0.063, we will get the acceleration. Is it clear? Is it clear, this question? Because the lift dimension already, it is at constant height. So it means the vertical forces must be balanced. Otherwise, it will either accelerate up or change, or move downward. But the force W sine theta is no, this is the direction of the flight. And so W sine theta basically is responsible for, that's causing a, because action and reaction forces are equal and opposite in direction. So as the bird pushes the air will push the bird in opposite direction, and that matches with the resultant force. The next question is on page 21. Okay, this graph is there. You can see when some birds take off from the ground, there is no lift initially. These birds push off from the ground with their legs. So as they push, because the position of the center of the mass changes momentarily, that's why you can see the resultant force is decreasing. But when they push the ground, so greater downward force, more upward force is there, and that create a resultant force against the gravity. That's how they're able to lift off from the ground. This is the same thing which I discussed, how a person can jump. With reference to the Newton law, explain how the downward force from the leg enable the bird to take off. Like example, say this is a bird on the surface of the earth. This is the surface of the earth, and the bird is there. Example, this is a bird. So earth is pulling the bird, that's weight, and bird is also pulling the earth with the equal amount of the force. Then when you compare the surface, so because there is a downward force, if I use a number, like example, if this was 10 Newton, this is just an example, 10 Newton. So bird is also pulling with a force of 10 Newton. But as the, and what are the Newton pair forces? The 10 Newton is downward force by the bird on the ground, and ground is also pushing with the same force, but in opposite direction. But as the bird pushed the ground, so as the bird is pushing the ground, what happened? More downward force. Like example, a bird apply a force of 20 Newton. So as bird apply a force of 20 Newton, the ground will also apply a force of 20 Newton, but in opposite direction. So now what happened? You can see the earth is pulling with a force of 10 Newton, but ground is applying a force of 20 Newton. So what is it? What it created? It created a resultant force. That's why the bird will lift or accelerate upward. So in terms of Newton law, how we can explain this, how a bird can fly. So what happens first, you can see the bird pushes the ground downward. According to Newton third law, the ground will also apply equal force in opposite direction, and that create a resultant force or unbalanced force, because that is not matches with the force of the gravity. Force of the gravity is less, but the force of a ground is more, and it create a resultant force. And if whenever there is a resultant force, the object will accelerate. That's why this bird will accelerate. Is it clear, this part? Then next question, page 22 and 23. This was 21, I guess. Yeah, 21 was there. 18C2. Use the graph to calculate the maximum acceleration. How to calculate a maximum acceleration? Look, this is the force which the bird is applying on the ground. So if this is a force applied by the bird on the ground will also apply the same force in opposite direction. So basically, the weight of the bird is acting down and the force of the ground is upward, and that will create a resultant like F minus W is equals to ma. So what is the force of the ground? The maximum force of the ground is about 2.05. I guess, yeah, 2 point, each is a 0.2, so it will be 2.04. So that's equal to 2.04. And the weight, you can work out the weight. The mass of the bird is given in the question, which is 0.063. So you can work out the weight, which is 0.063 multiplied by gravity, 9.8, and substitute the value. M is the mass of the bird, so you can get the acceleration for the take of the or lift of the bird. Is it clear? I'll share another link because less than a minute left, and remaining doubts I will discuss in that session.